Bismillahirrahmanirrahim. Assalamu alaikum, students.
وعليكم
عليكم
السلام ورحمة الله
السلام ورحمة
وبركاته.
الله.
So today we will start chapter number 6, and in chapter number 6, what we will study. So chapter number 6 is actually related with the circular motion. And this circular motion is connected with the Newton's laws. But here we will see that Newton's laws are related how. So normally we know that in the previous chapter, we have already studied the circular motion. So in circular motion, you remember that if a body is moving in a circle, this is the mass of the body, and it is moving in a circle with velocity v. So its velocity direction is changing at every point. This is the change of the direction, but its speed is constant. So that's why we have acceleration, and that acceleration is called centripetal acceleration, and its direction is towards the center of the circle. This is AC, centripetal acceleration. So here our target is to connect this centripetal acceleration with the Newton's laws of motion. So normally we will connect it with the second law of motion. So second law of motion is F is equal to ma. So this force we will connect with the force which is responsible for the motion of the body to move in a circular track. This is the acceleration. If I put here m, then it will become mac. So mac is actually the radial force, and this force direction is towards the center. And normally in a roughly speaking way, not strictly, roughly speaking way, we call it a centripetal force. But centripetal force is nothing. It depends on some other force. So how we can say this one, that it depends on other force? It is not a new kind of force. It is not like gravity. It is not like electrostatic force. It is not like electromagnetic force. So let's see here. If a body is moving in a circle and you attach this mass with a string and you want to move it in a horizontal circle, this is horizontal circle. So surely you will apply a tension force on this string. So this tension is providing the centripetal force. Centripetal force itself is nothing. Who is providing tension is providing the centripetal force. So we normally write AC is equal to V square R. So in this formula, you remember that AC and V, they are perpendicular to each other. So A is perpendicular to, AC is perpendicular to V. Okay. Here I want to tell you that centripetal force is nothing but some other force is providing centripetal force to change the direction of this body. If we cut this string from here, then the body will move in this direction, in a straight line direction. This is the common life example. But here we are relating this centripetal force with the second law of motion. Okay. So this is our target. Now let's see, the centripetal force is what? No. This is, if I put here m and put here m, then this is f of c, and this is equal to mv square over r. F of c is equal to mv square over r. So normally in language, we call it centripetal force. But actually it is, in real sense, it is not absolute force. Itself, it is not a force. It is provided by some other force. So who is providing? Let's see some examples. So examples are what? Examples are, let tension. Tension is providing centripetal force, where if you tie a mass of M and you are moving like this one, it is moving in this way. So this is the radius R and the tension will be in this direction because it is attached from here. This is the tension. Actually, the mass want to move in this direction. But who is responsible to move it in a circular track? That is the tension force, and this is equal to mv square over r. If m is the mass and r is the radius or the length of this string, and v is the velocity or speed of this mass. One thing, one example. The other example is gravity. You know that this is a sun and this is the earth. Okay, so earth is revolving around the sun. Earth is revolving around the sun. Who is responsible to revolve it around the sun? That is the gravity. Between it is gravity. This is the second example. Okay. The third example is the frictional force. So in frictional force, you know that the roads have some frictions. If you want to take a turn like this, road is a curved road. This is the curved road. And your car is moving like this one. And you know that on the road, there are some signboards of speed. The speed is 40 kilometer when you are taking turn. Reduce your speed. Maybe the 60 kilometer or 70 kilometer, not more than 70 kilometer. So if there is no friction between the tire and the road, between this tire and this road, then this car will move in this direction. So who is responsible to move this car in this circular track? It is the frictional force. So this is another example. Okay, the last example is the normal force. Normal force is also providing the centripetal force to make it in a circular track. Maybe you have seen that there is a round shaped room in the amusement parks, and the person is standing here. The person is standing here. So when it is rotating, he is pressing this wall in this direction, and the normal reaction will be in this way. So the normal force here in this case, the normal force is providing the centripetal force. Here the frictional force is providing the centripetal force, and in the previous, the tension is providing the centripetal force. The gravity is providing the centripetal force. If we have an electron is revolving around the nucleus, this is the nucleus. Okay, so who is the responsible to revolve this electron around the nucleus? And that is called the electrostatic force between the electrons and the protons. So here the electrostatic force is equal to mv square over r. Here the gravitational force is equal to mv square over r. And here the frictional force is equal to mv square over r. And here the normal force is equal to mv square over r. Our game depends on mv square over r. Okay. After this, we have some examples about this article. We have only one article in this chapter. Okay, the examples are this conical pendulum. Conical pendulum. Already you have studied and in your lab experiments. This is a simple pendulum. In simple pendulum, you are moving the pendulum like this one. It is moving like this one. And this is the simple pendulum, and you find the time period of this pendulum like this one, and t square is equal to 4 pi square L over G. And then you want to find the value of G 4 pi square L over T square and plot the graph between L and T square and then find the value of G by finding the slope. This is a simple pendulum, but here is the conical pendulum. So the word is showing the conical pendulum in it makes a cone. Okay, see, this is the pendulum and it is moving through this central point and its motion is like this one. Okay, its motion is like this one. I make it again. So you can see that its motion is like this one. So one position is here, the other position is here, suppose. So it is like a cone. Cone is like this one. Like this one. And this pendulum is like this one. This is the central line. That's why it is called conical pendulum. So here is the mass and it is attached with the string and the tension is upward and this angle is theta. So mass is vertically downward. The component of tension one is upward and the other component of tension will be in this way. Because if I extend this line, then this is the tension. This will be the, if this is angle theta, this is angle theta. So this component is T cos of theta. This front component is T sine of theta. And this is your radius R. Okay. So from this diagram, from this triangle, you can see that this is T sine of theta. And this is T cos of theta. And this is T. In this way, it is T. This angle is theta. So from this triangle, and this is mg. So T cos of theta is equal to mg. This is balanced by mg. The question is T sine of theta is what? T sine of theta is responsible for centripetal motion. This one. So we have two equations. One is this one and one is this one. So what we will do? We will divide 2 by 2 on 1. So I divide this equation. T cos of theta is equal to mg, equation number 1. T sine theta is equal to mv square over r, equation number 2. So T sine theta divided by T cos theta is equal to mv square over r divided by mg. So T will cancel and m will cancel with this one. This is v square over rg. And sine theta over cos theta is tan theta. And this is equal to v square over rg. So v square will be rg tan theta. And v is equal to rg tan theta under root. So here we replace the r in terms of length. How? You can see that if I, okay, I remove this line. If I make the triangle like this one, you know that this is theta. Now I'm taking this one. This component is what? This is, I take in the previous is the tension. Okay. So this is R and this is L. The length of the pendulum. So R over L will be sine of theta. And R is equal to L sine of theta. L sine of theta. So V is equal to L sine of theta multiply by g tan of theta and under root. So this is your V value. So here you can see the value of V depends on the length and the theta. G is constant, it's 9.8. So in this way, you can find the value of the V of the conical pendulum. So this is a formula for the conical pendulum. Okay. After this, we have another example. You can see in your book 6.4 example, and it is written maximum speed of car. So maximum speed of car mean that if the road is like this one and the car is moving on the road and the road has some speed limits. In the first slide, I already explained that if a car is moving on a curved road, this is the curved road, but not tilted, then the frictional force is responsible to move it in a circular track. Otherwise, it will go in this direction. So the frictional force is what? Mu s into mg. And this is equal to mv square over r. So here m will cancel and v square is equal to mu s into g into r. And v is equal to mu s into g into r under root. So here you can see that the speed depends on the radius. So that's why when roads are making by the engineers, they put its radius. Okay, this radius is here somewhere. And also, they also adjust the coefficient of static friction between the roads and the tires. They already put these conditions and then they are making the road. Otherwise, the car will skid and go in this direction. And they put the limits of the speed. If your speed is very high, then it's difficult. So you can also find the mu s value from this equation, v square over r into g. If you have this data, v and r, you can find the mu s. No, it depends on the problems, what kind of problems exist. Okay, this is the maximum speed of car. Here the road is curved but not tilted. The next case is the road is curved or banked, is curved and tilted. And tilted mean what? So here you can see that this is the road. This is the road. Okay, so this side is up and this side is down. And the angle is theta here and the car is moving in this direction. So the weight is vertically downward. The normal reaction is upward. In the previous cases, in the previous chapter, when we study the inclined plane, what we have done? This is the mass, this is the weight, and we make the components of the weight like this one. Now here we will make the components of this normal force. One is along this one and one is along this one, this side, because its curvature is this side, this side. So what we will do? We have normal has two components, one along y-axis and one along this x-axis. So if this is ny and this is nx, so nx is equal to, this angle is theta, nx is equal to n cos of theta. Sorry, not cos theta, here it is n sine of theta. And ny will be what? N cos of theta, because in this triangle, you can see it is like this one. It is like this one. And this angle is theta. And this is n X mean this side because it is along x-axis, and this is vertical side, and that's why it is called ny, and this is n. So n cos theta is equal to ny, and this is balanced by the weight, and this is equal to mg. Now who is balanced by n sine of theta? So n sine of theta is balanced by the centripetal force. Now we have again two equations. We solve it by dividing it. N will cancel with n, sine theta over cos theta will become tan theta, and this is equal to mv square over r divided by mg. M will cancel and v square over rg. So this is the same equation which we have derived in the previous conical pendulum, but we will not put here r is equal to L sine theta, because in that case, the pendulum depends on the length, but here it doesn't depend on length, it depends on the r. So what is the value of the v? V will be rg tan theta and under root. So here you can see the value of v depends on the radius of this curvature and the angle, banked angle. This is called banked angle or tilted angle. So here you can see the road is curved and banked or tilted. Same word, banked or tilted. This is the third case. Okay. The last case is this one. It is written in your book, loop the loop. Loop the loop mean what? Loop the loop mean you can take the consider an example of roller coaster. So suppose it is moving in this way. If you are here at the top, surely your weight is downward, and this your seat is not pressing up, it is pressing down. So the normal reaction at this top position, the normal reaction and the weight both will be downward. But when you are at the bottom, at this position, the weight is always vertically downward. The change is the normal. The normal will be upward. This is at the bottom. Now we want to write the equation at the top and at the bottom. How we can write the equation? N plus mg is equal to, who is responsible to make it in a circular track? Centripetal force. At the bottom, N upward, mg downward. Who is responsible? mv square over r. So these are the two equations for this case. If the body is here, r here in the left hand side, r in the right hand side, then left hand side equation or right hand side equation will be equal to n, because this n is in this way, and this is equal to mv square over r. So these are the equations which we will apply to solve the problems. Other thing is nothing in this chapter. So what you have to control, you have to control that Fc is equal to mv square over r, and this Fc sometimes is equal to T. Sometimes it is equal to T. You can see from here that if the body is moving like this one, and this is the tension, and more tension, more speed, more tension, more speed. So you can write this equation T into R over M into under root. So speed will be maximum if we have more tension, or the radius is more, or the smaller mass. So depend on this one. So one thing is this. The second thing is Fs is equal to mv square over r. This is for the frictional force. And the third one is we have checked with the banked road. So this is also the banked road. But in case of tilted road, the formula is the same as in the conical pendulum, v square over rg. But in case of conical pendulum, we take r is equal to L sine of theta. Just others are same. So this is all about chapter number 6. So we will finish this chapter. We have finished this chapter, and I will send you the problems and their solution. You will solve yourself these problems and their solution because it is easy. It is not a difficult task. So next time, inshallah, we will start chapter number 7. So this is all about chapter number 6. So if you don't have any question, or if you have question, you can ask me, and prepare your midterm exam. And next time,
Doctor,
yes,
I have a question about midterm.
yes.
How many questions in there?
Normally, we have 2 mid exams in the previous.
Yeah.
This is, I am saying, before Corona. Okay. So the exam was 15 plus 15. First mid, second mid, total is 30. Okay. But this,
Okay.
yes, but this time, that time it was 1.5 hour plus 1.5 hour. So total time is 3 hours. Okay. Now this time, I think the mid is only 1, and it will be 15 question, 15 marks, 15 question. Now this time it will be, I think, 20 question and 2 hours, I think.
Okay, doctor. Thank you.
Okay. So prepare your midterm exam with conceptual way, and inshallah you will solve it easily. Okay, so if you don't have any question, so inshallah see you in the next lecture. Okay, assalamu alaikum.
Thank you, Doctor. Wa alaikum assalam wa rahmatullahi